Good evening. Good evening, good evening, good evening. And welcome back, everyone, to more Voron 2.4 building. Finished off last time, completing the Afterburner, which is the name for the Hotend and extruder assembly thing, which is this big lump in the middle here. And due to many comments about me being unprepared, despite it being deliberate, what was I saying? Yeah, despite, so people have wanted me to prepare things a little bit more, so I've decided to prepare things a little bit more this time. We'll see if that makes a difference. You can let me know if it's preferable or not preferable. Before we get started, just a quick message from the sponsors. This video would not have been possible without our sponsors, Filler Farm and Big Tree Tech, so a big thank you to them for supporting Vector 3D. You can find out more by just watching some more, or you can follow the links in the video description. So there have been a few things happening between the previous episode and this one, part of which are me preparing some things, but there's no like major changes really. So I've done a bit of preparation for the Afterburner wiring because we've got the PCB mod to go in. So I'm going to get on with that first on the basis that I think a lot of this stuff is going to be super difficult or more difficult once I stick it all into the frame. So I want to kind of get as much sorted here as I can before that goes in. That sounds sensible. As far as I can tell, there's no real instructions on the wiring particularly, or when to do it or when's best. So I'm going to get on with that now. I've also, excuse me. I've also dealt with a number of additional printed parts, which is like panel clips and hinges and stuff for the whole enclosure. I thought I had them, but I didn't. So those are all printed out, ready to go now. And I've also swapped out the two motors at the back here. So as part of making sure we get all this wiring done, I've replaced out these motors for the LDO motors, which I'm planning to use, and are the ones which are in the bill of materials should be. They're the LDO high temperature motors, so they've got a wire on them, so I'm going to need to chippy choppy that as well, and do some crimpy there too. Everyone that's listening, can you give me a response in the comments, just so we know that the majority of people have comments and stuff working? There just seems to be a few things not working quite right with YouTube at the moment, and they don't seem to acknowledge anything, so it's all a bit... If the stream just randomly disappears at some point, that'll probably be why. So, yes, I guess I'm going to get straight on with it, and you can let me know any questions or whatnot you have as we go. So, going to start with some Afterburner wiring. So, yes. So we're going to obviously be putting this PCB in. We looked a little bit at it last time, but not a lot. So because I'm going to be using this wiring harness from Lineo, I don't need all the stuff that actually comes with this. There's a big connector. It's got like 12 terminals or something. 2, 4, 6, 8, 10, 12, 14 if I can count. Yes. And I don't need to do that because mine's already done on this harness, so that saves me quite a lot of crimping. But I do need the smaller one in here, which is for the heater, and I'm going to need a couple of the pins for that. So I think that's probably a good place to start, in fact. Now, getting this done in a suitable amount of space is a bit of a challenge. Ideally, it might be easier if you've not done much crimping before. In fact, I might have trouble with it as well, and I've done quite a bit, to take all this stuff away from this assembly. But since I've only just put it on there, I'm going to leave it there for now. If we do start to have problems, then we shall deal with it by taking everything off and sort of making it a little bit easier for ourselves. Good, all the chat and stuff seems to be working. Looks good to see. As I said, if the whole stream just disappears at some point, it's probably YouTube going a little bit weird, because that seems to be a thing that's happening at the moment. So just to give you a little bit of context, let's stick the camera in a little bit closer. You've got stepper motor, sensor, fan 1 and 2, or 2 and 1, whichever way around it is, heater and thermistor. I've grabbed the E3D motor thermistor cable thing because the standard bit needs a bit of an extension. We've got this little spacer that's going to be sitting on here, and this PCB which is going to be sitting in here. And then once that's in place, we have this cover which goes over the top of everything. Normally we'd have this smaller cover which kind of mounts in here somehow, I'm not exactly sure, somewhere there. But we're not going to be using that because we've got this larger one with this PCB whatnot malarkey. So first things first is I think I want to just double check as we go along that I'm not doing anything silly. So I've got a little black spacer that I showed you last time. Should be just enough for that to go through, and then I think it's an M3x16 that I'm going to need to screw this all together. Video blurry. It looks pretty clear to me. Might be your settings if you're having a blurry experience. Have you seen it's now recommended to use nylon washers on the toolhead PCB? It was mentioned last time. Some sort of this M3x16 looks a bit too long. Where did I just get this from? So this on here, this on here, on here, on here. Okay, that looks suitable. There was some talk last time about which spaces and what not to use. And I think I'm just going to carry on with what I've got here. So we've got this one fan here, but I've marked these cables already with a length that I think hopefully is going to be appropriate, whilst also trying to give me a little bit of slack just in case I do balls it up. That's the technical term. So these are all pre-marked, so we can get on with cutting the wires, and fingers crossed I don't make a mess of it. It's always like twice as difficult. Let's take this off again actually, now that I've shown you what we're doing. It's always twice as difficult when you don't have quite enough room to work to get wiring done well. So let's give it a go. So the first one is the second fan. This one came with the right length cable, which is really convenient, but the second one I think I just used out my own box here, so no specific size. Tools are going to be quite big in comparison to the space I've got. So this is a JST connector, JSTXH I think it is. I always forget the exact naming. Really useful tool, this one, can highly recommend. It's made by, well, this one is branded as standard, but there's other variants available. But it just holds the two ends and strips it really nicely. And it's really consistent, which is good. Now, it does come with a bunch of terminals and connectors in this particular kit. So I'll be using those personally. I don't like the ones that are on the strip like this, just because getting them off can not always be the easiest thing without damaging the connector, or it just takes a while. I much prefer the ones that are loose. They're a bit more expensive, but not a lot. This is when it gets really difficult. Yes. So we stick this in here till about here. Put this on here. And we have a nicely crimped terminal. Should have done the other one first, but there you go. Is anyone else having problems with a blurry video, or was it just one person? Seems like hopefully just the one person. And hopefully they've got it sorted. So I'm kind of hoping we're not going to be crimping terminals all evening. The plan, according to the title, is to do a little bit more than that. Right, that's one down. So we've got some white connections in here, some black, but just choose the one with the right number. That's the important thing. Right number of holes, that is. So it looks like, according to the other connector, black's going to go in this side. And red in t'other side. There we go. That was stressful. Let's do the motor now. Giving myself, I think, a little bit extra slack on this one because I really don't want to have to get another motor in the case that I make the wires too short and I can't connect it. I suppose I'd make an extension or whatnot, so it wouldn't be the end of the world. But it's just better to get it right, isn't it? The only downside of this is if you do get a bit of a wire stuck in it, it tends to it doesn't work properly, so you just have to make sure it's clear. This material looks like it's kind of stretched a little bit annoyingly around the things. I think it'll be okay. Just checking that we're going to be using the right connector. So this is the one for the motor, and that's JST again. So just the same terminals as we've just done. PA09 is that tool from the company that's annoyingly called Engineer, isn't it? Well, I don't have that tool. I have this one, and it works rather well. This is probably a little bit excessive, cutting the extra off the back of the terminals, but just seems a bit tidier. So we just do the same. Whack this in here. Oh. Then push the wire into the thing. Good as gold. Getting lucky today. quite often terminals, especially with these cheaper tools. I think I cut myself with my side cutters. Yeah, with cheaper tools like this, it's very easy for it to not go quite to plan. But we're getting very lucky today. There's another one. Bang on. Next. It's going to be quite a lot of this, I think, today. I could have maybe done this between the strings, but you never know what's going to be useful. So and one more. I've just realised I don't know the order these were supposed to be in. So there is a little bit of an instruction actually in the box here. It mentions the schematic works with spec steppers from OMC and LDO. If you have a different stepper motor, you will need to confirm which wires have continuity with a multimeter. Each wire should have continuity with only one other wire. These are the referenced pairs. So linear harness is this. Connecting bed leveling probe to the harness. For the probe connection to the printer board, linear harness for red is V+, blue is V0, and black for output. So we need to double check the sensor for that. It does allow for plenty of chit chat, that's for sure. So I'm going to just double check the harness. It's all in blue, my one. So this is, I mean, I'm not going to know really because the stepper motor is obviously just going to this whopping great connector here. We've got E0 and 2 wires going in, but not much to check really. I guess I put in the same as the Z motors. It's half tempting to leave the Z motor wires as they are, but maybe I shouldn't. So this is always odd. Black. Green, red, blue. And I'm really nervous about messing it up because it's like a 60 quid sensor. And with this sheath on the table, on the cable, it's just a bit more difficult to get right. Okay. So checking this again, still JST. Do need to double check the wiring though. I think I did look. So comparing the two. So my brown is V+. In fact, I don't need to worry about this, do I? I just need to worry about this because this goes to the PCB. Oopsie daisy. So I'm not going to be checking it directly against the harness. I'm going to be checking it versus the PCB. So I just need to make sure that these on the here go to here. So I got V plus is brown, so that'll be far right. Black is the signal in the middle, and blue is ground, which is 0 volts. Okay. Right. Concentrate. Right, open. Now we need some more terminals. Lost me for a bit. That's a bit worrying. I imagine for quite a few people, or maybe in particular regions, the stream's just not going to show up, just because YouTube's maybe having a bit of a mare about something at the moment. I can't believe I managed to cut my finger. I've just cut the skin. It's really... just very lightly. Just the top layer of skin. It's really bizarre. Anyway, you probably don't want to know that. Right. See if we can get these 3 JSTs on without making a mess of it. Can't even get the blooming terminal in. Ugh. One down, 2 to go. It's 2 down, 1 to go. When I'm doing this, by the way, I'm just trying to make the terminal flush with this top surface, because that will make sure the rest of the connecting kind of parts are in the right place, so that when it crimps down it doesn't mash the connector weirdly. This looks good. So now's the can breathe now that we've got that one that one done. Spare motor cable. So let's make sure we get this right. So that's going in there. Ground is that one. Which one's ground? Blue. Ground in here. Oh, I've lost which one it is. This one. Black is the middle one, signal. And then brown is V+, which is the other side. Whew. So let's just double check that. V plus, brown, black, middle, signal, blue, ground, 0 volt. Yes, good. Whew, that's that one down. Motor cable. So this one's a bit of a mare as well because of this sheath on the outside. Thanks for helping. Let's try and keep everyone watching that wants to. Thanks very much. So I have marked mine, so I'm not just cutting this randomly, although it probably looks like it. So hopefully that's going to go up to the right space. Cutting the ends here. And then because it's got this kind of fabricy stuff on the outside, this tool actually doesn't really cut it. Like, in both senses of the word. So you have to go a little bit manual with this. So firstly, I want to just do like 3mm or something off the end. And that just exposes the wires, so I've got something, I've got the electrical connection, and then even for the mechanical connection, the sheath does mess it up a bit and makes the whole wire a little bit too thick to get to crimp properly. So I'm going to cut back manually some of this outer weave. Probably quite difficult to see, isn't it? So just trying to kind of pry it back a little bit and cut it out whilst leaving the actual cable underneath fully intact, because that's what our terminal is going to grip onto. Doesn't matter if you go too far with this, because at this point in the cable it's not really doing anything. It's only problem if you don't go far enough. So there we go. Hopefully you can see that. We've got a few millimeters exposed at the end. Oh, that's very, very small. So there's a few millimeters exposed at the end, then a few of the plastic sheath, and then just the weave goes the rest of the way. Obviously you need to do that for both. Does help having sharp tools to do this. If your side cutters are a little bit blunt, you might find it a touch difficult to cut precisely. I mean, if you've got, if your wire stripper tool does it, then you're laughing, because my one doesn't, which is unfortunate. It's really good for everything else, but this, just a big fat no. Oops, daisy. So I'm trying to make sure you can see it a little bit as well while I do it, but it's really difficult with the whole afterburner sitting here as well. Right. So those are ready. Now this is not JST, this is the other, which like a microfit. But if I remember correctly, I did a little test and the same crimp tool works just as well for me, which is lucky. Now, where are the terminals? In this back here. I bought a wire stripper years ago at a garage sale. They are a cross between your style and the kind that cut the plastic sheathing. Best ones I've ever used. It is a bit funny, like wire strippers are... Oh, that one's crushed. Terminal's crushed. They're the kind of tools that once you get a good one, you're like really lucky, but actually trying to deliberately buy a good one without spending hundreds of pounds is a bit of a gamble, it feels. So this one a little bit easier to get into the tool. Hopefully we can get this on first time, no props. And there's props. I'm going to do this the other unconventional way, which is to put it on the wire and then start the crimp with the side cutters. Which really you shouldn't do, but sometimes it just works a bit better. There we go, pretty happy with that. So hopefully we can get the other one the same. Yeah, good. Whew. Now, I did try this connector as well, and there's a slight issue with actually getting it into the terminal. The back of it actually just clashes on the side of the PCB. So I'm going to cut this away a little bit just to hopefully get that to connect as it's meant to. Hopefully that'll now just go straight in. There we go, very nice. Now we've got to get the terminals in here. These are kind of non-polarized, so it doesn't really matter. As long as you put them in the terminal the right way around. Which way is it? That way? They have wings on the connectors, so as long as you've not crushed them in the process of crimping, they'll prevent you putting it in the wrong way around. Although now I can't get it in. Well, not that way then. Oh, there we go, and we're in. So that's going to come up here. Oh, a tiny fraction too long, but that's going to be okay. Better too long than too short. And then finally the thermistor. So the thermistor we can actually disconnect because we've got an additional connector in the chain, which is kind of annoying, but it is what it is. Excuse me. So we can just cut this off here. Separate the two. This is back to the JST connectors again. I wish crimpers are a good option. I'll make a note. How do you spell that? I-W-I-S-S. Thing is, once I have ones that I'm kind of happy with, it's very difficult to justify spending money on more. Which means I can only recommend these. These are SN-01BM. They're kind of a generic eBay lot. But hopefully with that model number you can find the right thing. Let's use them properly though. The PA09, in fact, I think most of the engineer tools, they're not ratcheting, are they? If I remember correctly. So they also don't disengage when you get to the right point. So I've set these kind of so that they release at the point where I want to. Whereas when you've got a free tool, it's very easy to overdo it. Right, I'm guessing it's very easy to overdo it. That's obviously the reason why they are sometimes not used. But having not used one, I can only assume. So, thermistor wire, doesn't actually matter which one goes in where, as long as they're both in. Right, so that goes on there. Get this back. Moment of truth. Hopefully now we can plug this in and everything will go in easily. That's it's not a promise, it's just a guess. Just a hope and a wish. So that's on there. So that's the end, the sensory doodad. Then we've got the stepper motor coming down here. Let's see if we can get this. Try not to break anything. That's that. Hopefully that will tuck in okay. Part cooling fan is actually the top one, isn't it? That goes around those ducts at the side. Ducts, not ducks. Hot end fan is the front one. So the hot end fan is the one that I did. So that's this one. And the part cooling fan is the other one. We've got the heater cartridge going up into here. And the TH0, thermistor 0, on here. There's also X end stop. Now, my X end stop's over on here, so I'm assuming I don't need that. Hopefully not. Right, so there are plans. I have been using the rat rig, not that much because I've not had that much to print, but I have been printing some of the parts that I've had to print for the Voron on the rat rig. It's been doing pretty good for the ABS Plus material. There are lots of plans. I have loads of parts I've purchased to put on it. I just haven't done it yet, and I don't have a sponsor lined up at the moment, so not done yet. But there's always hope. Jason from Audio Motors, good evening. if anyone has, sorry to launch it on you, but if anyone has questions about LDO stuff, Jason's obviously the person to talk to. So here we've got two kind of wide holes. You don't screw through these, they just go over the cap head screws at the back, and the rest should kind of fall into place. Should. Should being the operative word. Nope, I've not managed that. Sort of threaded in, but it seems to be spinning. There we go. Not quite sure quite where these cables are supposed to go, maybe. That area seems all that. I don't know, maybe it's okay. Whew. Thank you very much, Jason. It's very kind of you. $9.99 tip. Cheers. I was just saying I stuck the A and B motors on this evening, so those are the high temperature LDOs. But that's looking pretty good, isn't it now? We've got a really nice looking, oh, look how tiny that is. It's disgustingly tiny. Slightly different colour, unfortunately. This is the ABS Plus material that I've printed, and this is the original, the one I got from Print It Forward, which is the Eson ABS Plus. So the colour's very slightly different, which is a little bit of a pooper, but never mind. It's still looking pretty swish, I think. I figured I'd buy Nipex crimpers because they're less bad than the cheap ones I have. I have Nipex Ferro crimpers and some other Nipex. More expensive tool is always better in the long run. Yeah, I mean, as long as you know you're going to be using it, this is the thing. Sometimes it can be very easy to buy a tool for one project and then you never use it again. In which case, maybe buying an expensive tool, not great. But if you are planning to do lots, if you're into building things, then, I mean, tools that are good do last a lifetime generally. So 100% agree in that scenario. Oh, this is just lovely, isn't it? Something doesn't seem to be aligning quite right, but I think we're okay. So, harness, I think we now don't need to put in right this second. We'll leave that. But we do need to do these motors at the back because we want to have the microfit connector Watt City Doodah on those. So I'm going to assume we can put it up to somewhere here, and that'll just give us maybe a point where we can hold the connector and whatnot in place. I'm not totally sure, but there should be. I've cut it off now, so the harness should give us everything we need there. I mean, that's maybe going to be going up here, so I don't know exactly how the harness is going to work at the moment. So maybe I shouldn't have cut that yet. But there you go, it's cut now. Hopefully everything will be alright. We can always cut it shorter, we just can't cut it any longer. You can't see the colour difference after it's in dark enclosure, printing stupid fast. No, this is true. This is one thing I thought actually. There's lights. Love some good lights. Bit of RGB. No, I don't generally like. I just want some white lights in there because I like to see what's going on. But yeah, I mean the colour difference is not going to be a defining factor in the success or failure of the project. That's for sure. It's one of those things that's just nice to have, isn't it? Speaking of lights, has he clipped the LED on the toolhead PCB? What do you mean by clipped? It was on there. I don't think I need to do anything to it, do I? Does anybody know why all the 3030 black extrusion profile is sold out in Western Europe or EU? Probably the classic logistics problems that are everywhere at the moment. There's probably a load of it waiting to be delivered somewhere in a container or a number of containers. Which you prefer design-wise, the rat rig or the Voron? Man, I get this kind of question every stream. I need to get a good answer in place. It's difficult to say at the moment. Until I've finished this one and started using it. All I can say so far really is that the two things I've done, a majority of the build process, or at least a part of the build process, and the sourcing. Obviously, sourcing is much easier from rat rig because you just buy it and it's all there. If you want to do it that way, you can sort of self-source as well, but generally I think people are going to be buying kits. And the other thing is assembly. Now, obviously I'm not done yet, but in general the Voron feels bit more complex, a little bit less. The guide is not as good. The guide feels like more of a suggestion than like a how-to. So I feel like I've got something caught in my finger somewhere. That's really the main things for me at the moment. Cool, that's one. Should we do it the reverse way? No, let's carry on doing the thing. I think one of the big advantages with rat rig is you can buy a full kit. You might say, well, you can just self-source it and it's cheaper. Well, maybe. But what you do when you self-source is you take on all the risk for yourself. Risk just being like a, I suppose, generic probability of things going wrong, and then the responsibility is all on you. So if you buy something that's not quite right, it's your fault. If something arrives and it's damaged, then you've got to fix it. So with the rat rig, obviously, when you buy all from one place, if anything's wrong, that's their problem to fix for you, rather than for you to go out and have to sort on your own. So how did I wire? Oh, we've got these. Okay, we could just follow this. What we can actually do on these ones, because we'll have some open connectors, here we go. So that goes there. And we know the yellow wraps around the blue and the red. So we're going to get blue right at the side. Blue. Blue, red, green, then black. And now the other side. Now is probably a good time for a quick sponsor video. This live stream would not have been possible without our sponsors, Filafarm and Big Tree Tech. Filafarm are a 3D printing bed specialist based in Germany. Filaprint is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The Big Tree Tech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and RapRig VCore 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stool Guard for sensorless homing. Big Tree Tech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more. Now you're well informed. Blue, red, green, and black. That, hopefully, is all the wiring I have to do today. Don't we just love wiring so much? The crimp tool's even blue. Everything's matching blue today. It's worked out rather well, hasn't it? Can you maybe show quickly the Filafarm silicon heat pad on the aluminium hotbed? it's kind of all wrapped away at the moment, and sorry. We'll be getting it out soon when we get the bed all mounted, but I don't think it's going to be today. Sorry. So this is where we kind of finished the mechanical assembly yesterday with getting everything on the Afterburner, not yesterday, but the previous stream, getting everything installed. So now we're going to be belting the Z drive, and that's what I wanted to do with that wiring already, because otherwise I'm doing it whilst everything's in the printer, which would have made things even more difficult than it already was. So now we can move on to that process of getting everything sorted and into the frame. So as always, we need some printed parts. Let's tidy away this harness and stuff for the electrical thingamajigs. Got a bunch of these things. I think these are going to be needed. That's not. Don't know if I need those bits yet. More wires out the way. Oh, by the way, for those who have not watched earlier episodes yet and are maybe planning to later, I've added timestamps now to give you like chapters and stuff, so if you need to go back and refer to things and specific parts of the assemblies, that is on there. I'll be planning to do it for the rest of the episodes, but watching it back and getting those all sorted takes a little while, so they might not all be out immediately. Right, we're going to need some belts, printed parts. Z joints, I think that's the ones, certainly that match up to what I'm seeing on the screen. M5 nuts. Oh, so Daisy's still on the cable. M5 nuts, M5 by 30, that's M3s. M5 by 40s. Where's my M5? Is this the M5 by 40s? Oh, that's M3 by 30 as well. Oh. Am I going to need M3 nut? Apparently not. M3 by 30. M3 by 20s as well. Right. We can have a heated bed race. Well, when I have a heated bed, we can have a heated bed race. Well, I do have a heated bed. I don't have a installed or anything. That was one of those things that everyone suggested I leave off. So, there's a few different parts here, I think. Is there two different parts? There's these ones and there's these ones. So that looks like that. The wattage bed that I've got is 600 watts. I thought at the time that that was exactly what was asked for in the spec. It turns out it actually asks for less than that. But I somehow have asked for that anyway. Huh? That's that. That goes there. Oh, that's the kind of rotated jointy thing. It's kind of a DIY ball joint. I see. How are we supposed to tighten these screws? Oh. Damn it. Yeah, I think that's maybe where I got the confusion from. Well, it's definitely not a bad wattage to use. Seems about right to me. This is the most bizarro set of instructions I've ever seen. Jesus. Okay. Literally no help, is it? Literally zero. I need belts as well. Let's get some belts out. Let's switch back to this a minute. So correct me if I'm wrong, but I need 4 lengths of this, so I think we're going to cut it into half and then to quarters. Ooh, it's pretty long, isn't it? Felt like it was not that long originally, and now it feels very long. Right, that's 4 belts. This is super weird, isn't it? I've just got Fusion 360 open as well, so... Oh, but the belts are not in here. Useful. How do we tension the Z belt? Just pull it through. Wow, this is super mind fucking excuse my language. Third idler's at the top of the frame. Oh yes, okay. So looks like we can put these 4 pieces on here first. Oh, we need a thing in there. Oops, daisy. Oh, try not to break everything in the process. So we need some nuts. Oops, daisy. Not ideal. Not ideal at all. Okay. So first I think what we want to do is add in these, right? This seems like a good idea. So that needs to get in there. Oh, we need the thing in the middle as well, don't we? This. The instructions for belting a Voron are not interpretive, they're useless is what they are. Barely existent would be a more accurate way to put it. I mean, there's vague instructions and there's Voron instructions. So that's the M3 one, that's going to push all the way through. And we pray to high hell that we don't push it too far, because that would be an absolute nightmare. And we put the M5 one in, and careful not to push the M3 one out of the way. And then we stick a doobly on here. Now we've got to be careful not to overdo it, because we still have to be able to get the belt in at some point. Where's the other driver that I need? 3mm. How easy is this going to be? Which sodding side do we look? I think they would go the other way, wouldn't it? Okay, so that's in the right place. So those are tooths, right? Yes. So that's going to go down, 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 back up, around, over, through, job's good. Next. This one will do. And we're going to carefully shift this around. First these. What was it? M3 by 30 and 5 by 30. And then we need to whack a belt in. Oh, other way around. That's 2. Let's switch it all around. In this corner, I know you can't really see this one. It's just a bit difficult to show everything on the same time. So if I squeeze that this way just a touch, got the top camera at least. Yeah, I mean, it's a bit of a shame the instructions are a little bit not super great. Even when they're 135 pages long, they're still missing a lot. The good thing is you can get it together, but personally, I think good instructions are a good indicator of a good design. If you can't be bothered to write instructions, then maybe you made it a bit too complicated for yourself. So this on here, belt on here, that on here. I know, so that comment there, so they do say building a Voron is for more experienced 3D printer enthusiasts that understand how to build a printer without instructions. It's very well saying that, but every 3D printer is different. And when your printer is like almost specifically designed to be very different to all the pre-existing ones, like the Voron, there is no pre-existing knowledge that would allow you to know how to put this together. I don't think that's a very good excuse, personally, is what I'm saying. I know it's designed to be maybe an advanced printer, but I suppose you can argue like their target market doesn't want or need instructions. That just seems bizarre to me, like, especially from an engineering point of view. Engineering design is useless if somebody doesn't put it together in the way that it's intended to be put together. So the fact that you can kind of suggest that it doesn't need instructions just opens the floodgates to something being put together in a way that wasn't intended. It just seems bizarre to me. The last thing I want after spending hours designing something is for someone to put it together wrong. And then go, oh, it doesn't seem to work quite right. Where they also don't have exactly a target marker because they aren't selling anything. Well, this is true, but I mean, you can't design anything without targeting it at something or someone. They knew what they were designing for. That's part of designing, is having a criteria. If they didn't have that, then I don't know what they were doing. I'm sure they would have done. Right. So that's all the belts and dooblies put on. So now I think I can put it dans le printer. Maybe. So there was a suggestion just now about using the little stops on the carriages to hold everything in place while you set it up, and I think that's a blooming fantastic suggestion. So I'm going to do that. Oh, we've got to... Hopefully that's not needed. So let's get this printer in. Ooh, try not to run over the existing assembly in the process. Oh, I can show you a thing that I did. So I don't know how much you've watched of previous streams, obviously, but basically I was kind of annoyed that these bed rail positions were just kind of random. So I've made these little 3D printed jigs that should be about the right dimension to just get it somewhere close to where you want it. And then you can tighten them in place, and your bed rails should be close to where you need them. They'll be reasonably square. And then you can sort them out. The second one obviously is you can move according to the final position you need it. But it's good to get something close rather than what I ended up with, which was just a big skew rail. Oh, that's just push it against it. Job done. Not very much plastic, it's a bit, but valuable to have, I believe. I think so what Beefingers says there is, I think the long and short is that the printer shouldn't take a work week to build. That is not what I'm saying. Having something take a long time and not be well instructed are two very different things. I don't mind it taking 40 hours to build. That's fine. But as long as there are some sort of clear steps to follow along the way. That's, I think, the minimum for what you can call instructions. So I'm going to stick these up here. Move these little rubber stoppers up above that screw, and that should hold hopefully everything in place just long enough for me to assemble the whole lot into place, and then I can take them out or move them back to the bottom or whatever I need to do. And you can't see anything because I'm twit. Whoop. So yeah, this up here, this out of here, back into here, and let it go. Oh. I think when your screws are done a bit tight, it twists the rail a bit, so I might need to, let's just do it now. There you go, much better. I'm an automation technician. I've never built a printer before, but I did not have any problems with building my 2.4. So maybe it also has to do with how good your technical knowledge is. I'd like to think my technical knowledge is reasonably good. Like, I've built a lot of 3D printers. I've been an engineer for like a decade, so you know there's that. M3 by 20 screws, so 4 screws to get everything bolted onto the carriages. I think these are probably worth doing independently, and then we'll stick everything on top of them afterwards. That's one. That's oh, wrong screwdriver. Yeah, I do get that is basically kind of a hobby project. I mean, I think they're making some money off it through affiliate links and stuff, which is fair enough. But it doesn't mean I can't critique it. Like, it's kind of why I'm here. My point is not to slam them for not doing it right, it's just to let you know how I feel about it and what experience you can expect. That's more what I'm getting at. I've lost track of the conversation now. Big thing is that the manuals and documentation haven't caught up to the sudden popularity Voron has been seeing for the last year. Yeah, I know that with the start of all the kits and stuff, obviously loads more people have got involved. There's obviously been more YouTube content, etc. Obviously CNC Kitchen did a Voron 0.1. You've got Nero 3DP, who does everything. Tom's done one. I'm doing one now. So definitely getting a lot more attention than maybe they had anticipated. And I think that did start with kits becoming available. Right. So that's those in place. So they hopefully now should be able to hold this whole carriage. The carriage. Ooh. So let's give it a whirl. Let's sticky this in here. Oopsie daisy. Excuse me. Coming through. Don't mind me. That's it. Ooh, carefully does it. Over the top. Jumps again. And we're on. So let's make sure the belts aren't all twisted. That one's in completely the wrong place. That one needs to be over there. That one needs to be over there. Right, so how do we do this then? So we want to bring the belt down close to us through that pulley at the bottom. and then back up. Oh, what an idiot. Caught around the frame. Star Fabric, not seen you in a little while. Good to see you. Yeah, I mean, so someone mentioned there about it being easy. So then obviously in my mind there's like the difference between easy and long. Like a build that takes a long time isn't necessarily difficult. I would say this is quite difficult because the instructions are quite sparse. I've seen other people argue like if you find anything building difficult then you're an idiot, basically was what they were saying. All you need is a screwdriver and you just take it apart and put it together, it's easy. But I think there's a lot more to it. And there's also a difference between just putting something together and making a good job of it. So I'm going to make sure these idlers at the top are reasonably loose, I think, because I want to keep oh, that's the other way, isn't it? Make sure I get maximum adjustment. We'll leave the belt loose for now. I want to make sure everything's working properly, I think, before we cut those out. And we've got this to go up through here. Hopefully I'd put the nut in. Yes. I'm not sure how, I mean, my guess we don't want it tight because the whole point of this is that it hinges a boat. And if it's tight, that won't work. Let's do this one next. So, same as before, belt goes down, teeth facing inwards. Let's try and make sure it's not twisted. Come on. There we go. Oops. Again, I'll keep hitting my head on that blooming camera. Let's get the idler loose. And these loose. So I'm already seeing that the carriage at this end is too narrow, the way I've assembled it, because these two things don't sit either side. Either it's one, so you can see maybe, no, not really from that angle. If I set this, like, is it the A motor to the right position, this one's off by like 5. So obviously that extrusion, the way I've got it in there, not great at the moment. That's going to need plenty of adjustment, but I think it's designed to be like that, so it's not a problem. We just need to be aware of it and deal with it. Let's get this maybe a touch looser. Ooh, throwing things all over the shop. Right. Yeah, this is going to go in even. Just by the looks of it. I'm not sure that's throwing into the nut though. Ow. Crushed my finger. So, maybe I can explain this a little bit better from this side. So, the way that this is assembled, I've put these ends in as far as they go, and they need to be further out. So, I don't know if this is when you're meant to do it, but I'm going to do it now. Hoping it's just as easy as taking these screws loose. Do some each side, so that's some off that side. Now I'm not saying this is the final adjustment, but in order to fit everything I do need to adjust it, so it is being done now. This one I also left loose intentionally. Why don't I loosen both sides at the same time, Adam? That would probably be a good idea. Yeah, okay, so the reason I'm doing both ends, I don't want the nuts holding it together sticking out either end. So that's, look, I think there's more comments still going. Yeah, I've just noticed my belt's getting tight and got literally zero spare length to do anything about that, so hopefully it's not a problem. Right. So glad I don't have the bed in there as well to lift. So, let's come on over here and do the same again. Down through the basement. Loosen the idler. What are we at? 139. Let's do a quick sponsor.
This live stream would not have been possible without our sponsors, Filafarm and Big Tree Tech. Filafarm are a 3D printing bed specialist based in Germany. Filaprint is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The Big Tree Tech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and Raprig V-Core 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stool Guard for sensorless homing. Big Tree Tech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more.
An actual ad break. I was not expecting that. How are you not expecting that? I'm guessing you've not watched the others, because I do them twice on every episode, as well as the short one at the beginning. Got to get paid somehow, my man. Because this is an expensive project to do. Wow, we actually made one. Wow, I actually did. It's much easier, and I think it provides a better, more consistent message about products if I record something rather than just read it or something like that. Huh, why can't I find the hole? Yeah, I did them for the rat rig video, VCore 3 as well. In fact, I did one for the Sidewinder as well, did I not? Maybe not. Yeah, I've done them in the past, I think. As I said, got to get paid somehow. Right. Oh, by the way, don't forget to like the video. Sure, go for it. Please don't take that statement out of context. The one about the hole, that is. Right. This looks like it's in a Tiswas position as well. That's the flush end, so this needs to come... Oh, this is why this is this. Oh, that's annoying. Oh, you... I can't... Ah, Jesus. So... This length, I need to adjust it the same as I did the one at the back, because at the moment that wants to sit over there and that wants to sit over there. So they can't both sit in where they want to sit at the same time. So in order to do that, I've just loosened these screws and thinking I can push that way. But I need to loosen the screws in here. To do that, I need to get rid of this. What the hell? I guess I can just do this. Yeah, okay, I'm complaining a lot for something not that big. It's kind of annoying. But not the end of the world, I guess. I was just about to complain a whole lot more. Oh, I can't. I'll put that in, get this in the right place, make sure that's happy. And then do the top ones, and then I'll take the bottom off again. Right, I might be skipping ahead in terms of the setup for this. Seems like as good a time as any to do it. Of course, bit of a workout lifting this all over the place. Let's put that stopper back in there. So, going to do exactly the same with this one. Front, we want to keep the same. The front was like the reference position, so we're going to adjust from the rear. You can't see this. Sorry. Doing exactly the same thing though. This screw's really tight for that exact reason. It's not quite aligned proper. What? Oh, got to take the rubber stopper out, otherwise it's not going to go anywhere. So let's bring this back up. Tighten that into position, hopefully that should center. And then we do the top ones to hold it in place. And then we come back to the bottom to get those in place too. And this one back up here. No, that's not worked. That position is not correct. So I think we're going to need to loosen a little more somewhere. For some reason, that's not worked. I think it may be this sort of thing. Might need to loosen all of these again. Next thing to worry about is, does it stay aligned when I start moving the whole thing up and down? That's the next problem, isn't it? Okay, this is much better now. Doesn't spring back. So let's do these top ones. And then this lot as well. Right, I'm so warm today. Oh, this is still not right. How the dickens? Oh no, I think that's maybe okay. Whew, right, let's move these rubber stoppers right down to the bottom again. At some point, probably don't want them in there at all, but oh, if I can even put them back in now. Well, that looks pretty remarkably good, doesn't it? Blooming fantastic. That's a printer, that is. How easy is it? Well, you'll see, because it is a fully enclosed design, so we'll definitely be getting there. These belts won't be here. These need to be trimmed off to the flush. To the flush? They need to be trimmed off flush. But the panel should sit on the side without a problem. It does look great, doesn't it? There is a particular style about it which is somewhat appealing. Regardless of how it prints, it just looks pretty cool. Right. So I might have skipped over a whole bunch of instructions here because I've just kind of winged it. That is that. Put those in there. That on there. That's what I did. LCD module. Adjust the X. I just spent 20 minutes adjusting the X gantry, didn't I? Oh, this. Yes, this. That looks absolutely perfect somehow. Totally by accident. How's that worked out so well? That feels pretty good to me. There will be 1 to 3 foam tape between. Yeah, foam tape's a thing, isn't it? I've just realised that. So, with all the panels, you've got these clips which go on the side, and I've just printed a load of them. And after looking at this today, I've realised that that could be problematic. Because what I was going to do is forego the foam tape, so I could just use the default clips, of which I've now printed all of them, which is quite a lot. But now, having seen this, I realise that that foam tape is going to be, I think, somewhat essential to making sure we have the clearance so it doesn't just scrape on the panels. So that's a thing. Might have to reprint all of those. Yay! God damn it. I don't think it would rattle too much because my panels are really kind of soft. I mean, they probably... The panels are quite soft, so the default clips do crush the panels a little bit. But because this is obviously so close to the side, if that panel is flush with the extrusion, it's not going to work. You need that foam tape to offset it. So I might have to print all of the clips again. Bugger. Oh dear. I believe the default clips already account for 1mm foam tape if you work with spec side panel clips. So the foam tape I've got is this, which is quite thick. I don't think I could get the whatever it's specified. I don't know how thick that is. It's like 3 or 4mm or something. It'll obviously crush down, but yeah, so this is uncompressed. It's about 3mm thick. I mean, modifying the part is not a problem, really. Let's have a quick test. The next part is to carry on with the LCD and skirts, and I think, seeing as we're nearly 2 hours already, I don't think it's worth me starting that today. So this is the standard clip, which has 4mm, 3.6mm, has some millimeters. 3mm. Damn, this is 3mm. So my panel itself is 4, and I was planning to just crush it 1mm because it's quite soft. But these ones, which are the ones for the back panel, are designed thicker, and I think that's going to be more appropriate, so I might just have to print loads of these ones instead. That's about 6mm, which I think... So I've got a test piece here, So, I mean, it's not going to work at all with the belt on here. But if I hold that up against here, I don't know, it might work actually. Has anybody tried it? It's probably not worth the bother. Might have to just reprint every darn clip. This clip certainly fits better. Oh, poopy poos. Look at all this stuff I printed as well. This whole blooming bag of pieces is just going to be thrown out and start again. Ah, yay. Right. So, six millimeter panel clips, 12 of those I think is what I need. So I have to get rid of all the other ones. So instructions wise, obviously we made it to the end of Z blocks, carriages, etc. for the Z belts today. A couple of weeks in with the rat rig now. How do you like it? Probably check my review. That's probably the best place to find out my thoughts on it. So yeah, the next thing is LCD module. I'm already not looking forward to having to do these heat inserts, which are somehow randomly facing each other, making them very difficult to insert. But that's what we're going to be doing next. So that's going to be start of next episode. So it will be all very much a skirts-based episode to begin with. I don't know how far we'll get, obviously. Some electronics down there as well. So we might do a weird time for the next one. We're going to be starting to look at the Big Tree Tack stuff, and they have asked that I do a time that suits them, which for me is about like 8 o'clock in the morning. So 8 AM British summertime. So if you want to check that against your times to see if you might be able to attend. So that might be a thing. It might not. It's really inconvenient for me, and I'm not sure much of my audience is available at that time to watch stuff. So we might not do it because there's no point doing something that nobody has availability to watch. Anyway, that is it for me today. I think we made some really good progress. All the wiring done for that Afterburner PCB. That was a breeze, thanks to some swift preparation. Z-belts, my goodness, instructions were not very much help, were they? But we've absolutely nailed it, I think. Probably, mostly-ish, just about. So that's all good. Definitely all starting to look like a proper printer at this point. And it has the weight to match. Oh my goodness. Starting to look like a real Voron now. Like a big boy printer. There's 2 8 o'clocks in a day. Oh, that's 8 AM. As opposed to, I mean, 8 PM is like more normal time, isn't it? Yeah, they're thinking 8 AM. But if there's nobody available to watch it, it's kind of pointless. Whew. It's looking pretty sweet, isn't it? Liking the blue as well. Looks flipping awesome. Once we get that blue harness in there through the chains as well, that's going to be mwah, bellissimo, I believe is the term. Anyway, yes, hopefully you've enjoyed it. For those that are watching, hopefully it's been useful. I'll try and get some timestamps on this one as soon as I can. Maybe tomorrow morning. Yeah, don't know when that's going to happen. Pretty busy now. Up until TCT next week. If you're going to TCT next week, I am, so might be able to see you there. Obviously, if I'm in the middle of an interview, probably don't interrupt, but any other time. Come say hello if you're around. It'd be great to meet people that have watched or want to say hello, whatever. Just come say hello, but obviously not when I'm in the middle of an interview. So yeah, that's going to be it for me today. Thank you very much for watching. Hopefully it's been helpful, and I'll see you in the very next one. Goodbye.